I just titled today's as PTC Creo. We will be covering quite a few topics. The general gist that we are trying to capture or convey in today's session is that there are a lot of advanced features to Creo that really makes it a great tool for all of your design and even analysis needs, but that it still is easy to use. So you have a great ease of use story as well as highly advanced tools, which we think makes it a great choice for CAD tools. So just a quick intro. My name is Stuart Weiler. I'm the Director of CAD and PLM at Elite Engineering. Elite Engineering Services is a part of the Elite Aerospace Group, and we are a manufacturer as well as a PTC reseller. So we have a couple of factories where we do a lot of design and manufacturing. We use PTC tools. So throughout our factory, you will see people using Creo and Creo View and Windchill, a little bit of ThingWorks and Navigate, and we're even starting to use a little bit of AR as well. So we are a partner with PTC because we truly do believe in the products, especially Creo, as we'll be discussing today. So again, just a little bit more about us. We, again, are a reseller for PTC and service provider, which means that we can help with all of the various tools. You can see the PTC tools down at the bottom with all the different logos. So there's MathCAD, ThingWorks, Windchill, Vuforia, and of course, the centerpiece of today's conversation is Creo. So without any further ado, I'd like to introduce Emily Pinto. She is with the Virtual Center of Excellence at PTC, and she'll be giving us a bit of a tour. So you'll see a lot of different modules. And again, if there are any questions, please put them in the chat session, and I'll be happy to address those. Or again, at the end of the call, we'll be happy to allow everyone to unmute themselves and ask away. So thanks again for joining. And Emily, whenever you're ready, I'll let you share your screen.
Great, thanks, Stuart. So hi, my name is Emily. Like Stuart said, I work for PTC in the Virtual Center of Excellence. My group, the Virtual Center of Excellence, we specialize in giving overview demonstrations and talking all things PTC. So I specialize in the Creo suite of tools. So all of the different extensions and capabilities that Creo has to offer. And I will share my screen. I have a presentation to go through today. Like Stuart said, we have quite an agenda, quite a full agenda. So I'm going to try to move quickly through everything. But if there's any topic that jumps out to you, please feel free to follow up after or say something to Stuart later on, because there's a lot more information than just what we're showing today. So unfortunately, we can't get through everything Creo. We have a lot of different suite of tools, right, for all sorts of different parts of your design process, from analysis to manufacturing to automation and design. But today, what we're going to talk about is why Creo. This is our introductory, kind of our introductory demonstration and presentation to say, what is Creo all about and how does PTC see it moving forward. And then, of course, we're going to jump into some of the modules. So the first one is our Creo Unite technology and collaboration. And that goes along with our flexible modeling tool. So we'll talk about the Unite technology capabilities there. And then interactive surface design, which is our module for a highly surfaced, highly surfaceable geometry. And then advanced assembly, which is managing large assemblies, collaboration, and top-down design. And then our cutting-edge integrated technology. So just to comment on some of the other things that Creo has to offer. Hopefully this will give you a good sense of what Creo is all about. So let's start with why Creo, right? So we have a lot of different reasons why Creo is a very usable and effective tool for a lot of different people, right? And one of the reasons here is because the way PTC has developed Creo is to suit a lot of different needs across the board, right? So we focus on accelerating product innovation. This has to do with ideation, creation, and modification. So as fast as you can think of it, we want to give you the productivity tools to be able to design it, because really your designs are only as good as what you can get down on paper, right, or into your CAD software. So making it very easy to design whatever product or industry that you might be in, that you might be designing, finding tools that allow you to streamline that process, get detailed where you need to, but stay high level, simple, easy to use where you don't. So a lot of flexibility in how you can work in Creo. That's what we try to provide, so that it can be really simple and straightforward for as many people as possible. Then creation and modification, giving you the tools to create a lot of different designs, create them quickly, easily, and then modify them down the road. So giving you the tools to build models that are going to be flexible later on. Greater reuse of any designs is another area. This talks about our Unite technology. So Unite is a technology embedded into the core of CAD, and it does a couple of things, right? It's a geometry recognition tool, so it helps with our import and opening non-native geometries. It also powers our flexible modeling tool, which is a tool that allows you to make edits and changes based on the geometry that you see in the design window without affecting or needing the feature tree or the model tree. So really great for non-native data. And then replace assumptions with facts. Creo has a whole suite of options, depending on what you're designing, that allow you to validate, investigate, analyze, simulate, all sorts of different things, including our IoT that we have. PTC is also provides an IoT solution, so Internet of Things, where you can actually bring data into Creo to help power better designs. So actually using information from the real world. So a really wide range of capabilities. And we can talk about some of those here today. So we can start here, and this is a slightly older version of Creo, but it's going to be very similar, right? Our layout's the same. So your model tree's down the left, your toolbar's up at the top. You have different tabs for what you're doing. So this is our modeling tab that you see here. And this is our PackBot. And the PackBot has this little camera that we're going to look at some edits to that. So right from the mini menu, we're able to open up this part, the sub-assembly from the main assembly. And that's just one of the quick ways to do it. So you can do this either from the menu, from the model tree, or from the design window. So if we want to make an edit, that's very easy to do. This right here that you see, this is the freestyle modeling tool. So this is actually a tool that's as embedded in Creo as the parametric modeling tools that I'm sure everybody's familiar with, parametric modeling. But this is our subdivisional direct editing tool, where you start with a primitive shape, a sphere or a cube, and then you add these nodes, and you can push and pull on them to get them into the shape you want. So this is really great in a lot of different use cases. One, you have this great organic geometry without needing any kind of surfacing tool or experience in surfacing. So that's a really great way to use this. Also, a lot of times coming up with design variations. Hey, let's see what this looks like if it's wider. It's much easier to just pull that and drag it out than maybe changing it parametrically. So talking about design variations, another tool inside of Creo is the design exploration session. This is one of my favorite tools inside of Creo. And what it is a session for managing different versions of your model. So if you've ever tried to explore different ideas for future changes, and you've done the copy and save as, and then you make changes and you branch off that and you save as a different file folder. That can be, it's a common practice in the industry, and it's really not very effective or efficient. So what this tool does is it gives you this checkpoint tree to kind of manage that for you within your Creo session. So if we want to make changes, we have this entry checkpoint that we've come in as the first one in the checkpoint tree. And that's going to be the model we've started with when we open the session. So now we're in this sandbox environment where there's no risk of overriding that original model. We can always go back to that entry checkpoint, branch off in a different direction, discard the changes that we've made here. So it's really this free space to make a lot of different modifications, save them along the way, and then toggle between all the different checkpoints you have to say, hey, which one do I like better? So here's a simple change, right? This is a simple appearance change. We'll use our appearance library as well. So if you want to sample a color, we have a lot of different options for coloring your pieces: texture, bump, reflectivity, glossiness, right? And this is a really great tool. We also have extended capabilities. So our Render Studio, which is powered by Keyshot, is a tool that allows you to create actually photorealistic images and renderings of your product. So really great for advertising or whatever it might be. So if you like this version, or maybe you're not sure, you want to save it to come back to it later, or you're about to make a change you're not sure about, so let's save it at this point. You know, add that to your checkpoint tree, and then you can make further modifications. So for example, here, we want to look at this sketch, this lens cover sketch. And so what we want to do is extrude, and you'll see that it gives us the basic options for extruding up at the top through surface, right? Units, do we want to shell it, which direction? And then that placement properties options buttons will have further details. But like I said, Creo allows you to start simple, right? Click that simple extrude. It gives you a preview in orange, and it starts you with a unit, and then you make the changes as you need to. So it's fast, it's easy, and if you don't need to get more detailed, it's just a couple of clicks. If you do need highly detailed, you know, nitty-gritty control, you have those in those further menus. So really a great way to, like I said, streamline processes for a lot of different people who need different things out of different tools. So we also have an appearance library in terms of material. So if you want, you know, a plastic or a glass, we also have in our simulation, for our simulation capabilities, a full material library to use with the properties, material properties. So as much that can be built in, right? PTC tries to build it in. So here we have an added lens cover, looks good, and we're ready to move on. So, you know, from here, we can push this to our master copy. We can exit without saving. We can save it, bring it up in a design review. And we actually have a button that allows you to take this, place it in augmented reality with really only a couple clicks. I think it's like 4 or 5 clicks to bring this into an augmented reality view. And then you can email it to anybody who you want. Your IP is protected because it's just your surfaces that are visible, and you're able to have anybody in the world pull that up on your desk and walk around it and see the changes that you've made, including all the different versions from your design exploration session. So that's just a little sample, but we can move on to our Creo Unite technology. And so we saw a little bit of this bringing in some information from, right, if we have non-native information. And really this helps with a lot of different areas. So collaboration is a big one. People need to collaborate across different tools and platforms. And as you know, if you work with vendors or manufacturers or customers that are working on different platforms, right, across the industry, this is something that, you know, concerns users of CAD programs. And so we really do our best to use this Unite technology to make it as simple as possible to work through. So to incorporate different types of CAD data in the industry, this is typically a difficult thing to do, right? This is a challenge that PTC wanted to address with the Unite technology. And that's because working across platforms that it's not very effective, it can be costly and it can delay projects. So this is really a focus where we need to provide a really good solution. And so that solution is Creo Unite, and it allows you to consolidate and collaborate across different platforms, as well as power a flexible modeling tool, which allows you to make changes without the feature tree. So kind of goes along with that non-native data. So the Creo Unite allows you to import, converts non-PTC CAD data to Creo objects. It also gives you the ability to open. So if you would have a collaboration extension for one of the major platforms, CATIA, NX, Inventor, SolidWorks, you can actually open it in its native file format inside of Creo. So there's no geometry conversion, which means there's no translation errors, there's no failed geometry, and you can use that in your assembly, reference the surfaces, right, to build Creo parts around it or whatever it might be. And it actually maintains the link. So if somebody updates that SolidWorks part that you have opened in Creo, you can simply update it, and anything that you've referenced, right, if you have a tab that you've referenced, that'll all change with the new update. So really allows you to collaborate very easily and avoid import errors where it's not necessary if you're just adding it to your assembly. We also have the opposite direction, so save as. You can actually save Creo data, you can save Creo models as a different file format, not just your typical standard step or IGES, actually CATIA or SolidWorks. And what this means is that it's going to open in that format, it's going to open in that platform without any geometry errors, right? So just like you can open it in Creo and have no translation errors, you can do it the other way as well if you're sending people information. And so we really have a lot of options there. And I already mentioned that automatic update, where if you have a part opened as the native file format inside of Creo, right, they make changes to something, you get the update, no problem. And now another part of the Creo Unite technology is the flexible modeling tool. So this allows for fast, flexible editing of CAD geometry from any data source, so imported non-native data or Creo data. And the challenges that PTC wanted to address here, right, we have a couple of things, and it all comes down to efficiency, delayed over budget projects, less time and resources for innovation, right? We have lost market share, revenue, profitability if you have efficiency problems, and working between CAD platforms can be a very inefficient part of your process. And so flexible modeling is a really great way to solve some of those challenges. And so what it is, it's very easy to use. It simply recognizes the geometry that you have open in your design window. It doesn't look at the feature tree. So CAD neutral, or sorry, Creo neutral, SolidWorks, CATIA, whatever it might be that's open in your design window. You can simply select on geometry features. Creo will be able to recognize those as geometry features, and then you tell it what it is and how you'd like to treat it. So you say, this is a cut. And then it'll give you options that you would typically have for defining cuts, or you say this is a pattern, and it'll give you, it'll find the other instances of that geometry, it'll find the pattern. So it's really seamlessly incorporated into Creo. It's just, as easy to use as your parametric or freestyle modeling. And it's very, very intelligent. So it can really become very powerful depending on how you're trying to use it. It can do a lot with just these simple commands. So like I said, it recognizes the geometry, and it allows you to model that as if you did have the feature tree. So you're going to get back some of those capabilities that maybe you lost from working between two different platforms. And then that also propagates. So it automatically will replicate edits of patterns or symmetric geometry, so you can add to it and make changes that way. So now I have a demonstration of those. So let me switch gears here. Okay, so here's an example of our Unite technology. This is a razor head. Again, we're in a slightly older version of Creo here, but the interface is generally the same, and the tools that we're working with today are just as relevant. So we can see here that we can open, this is, for example, is an NX file. Of course, this works. The collaboration is available for SolidWorks, CATIA, NX, Inventor. But you'll see that this opened very quickly and easily, right? There's no load time. There's no geometry failure. You can see in the model tree, it's actually loaded in as that native part, right? The little symbol is different. It's an NX part. And this is great if we just want to assemble, put it into our assembly to build our Creo parts off of it. So for example, if you have a sheet metal part that you've been designing, but you wanted to wait for this motor to come in, right? You make razors. This is a razor head. You make razors. You don't make motors, but you want to make sure that it all fits together seamlessly, because big chunky razors really don't sell well. And so what you have here is your sheet metal casing that you put on it, but you wanted to wait for the motor to see where those tabs are. And as we can see, those tabs need to cut through this sheet metal. So that's not a problem. We can make edits to the Creo geometry referencing the part that's opened as an NX part. So we can design around it and integrate it into our assembly completely. So here we're using this is a tool called Copy Geometry. So all we're going to do is actually copy the surfaces from that NX part and say, hey, I want to use these surfaces in my Creo part. You're actually going to copy those into that sheet metal part so that you can reference them even if that motor isn't open. And so this makes it a very seamless process to incorporate a cut. This is a user-defined feature, so if this is a cut you make all the time, have those definitions already predetermined and then just choose the reference geometry. In this case, the reference geometry is the surfaces from the imported part. And then if you want the second cut for the other tab, right, 180 degrees would do the trick. So now another change or another piece of geometry that needs to be really snug against this motor would be the rubber bumpers on the side, right, holding this in place, helping dampen that vibration, whatever the purpose of these might be. You wanted to wait for the motor so that they are all snug together. So you can simply activate your Creo part. You can copy the geometry from the motor, right? Even though it's not converted to Creo, we can use those surfaces as a reference. And then we can start designing. So a quick example here, if we go into the sketch and then we choose an extrude, again, you get that orange preview. We want up to selected, which you can choose from your toolbar, you can choose from your mini menu. Very easy to do, and it creates this for you. So this is all, very good. It's all very smooth. But what happens then if somebody makes a change to this motor, right? If this is, there needs to be some kind of a change made and your vendor, your supplier says, oh, I have the update for you, I'm going to send it over. Well, that's not a problem. So if you have this already designed and you get the new NX part, all you have to do is open it up and it'll give you a notification actually that something's out of date. So as soon as that new NX part is in your system and you open up the assembly that has it in it, right? This is the shaver top level assembly. This is for the motor. Down here, you see a little flag with 2 notifications and it says there are 2 outdated features. So you can actually select those and locate those in the model tree. It'll pull them up, it'll highlight them so that they're easy to find. And here it says this copy geometry has moved. So if we take a look at that, we can either have it automatically update, manual update with notifications. That's what we have chosen because we got that notification, and now we can manually change it. So what you're going to do, you have a couple of options, but the show differences one is very useful. So here you can see the outdated component. That's the gray one where the cut is still made. And then you have the orange component, which is the changed one. So you can turn those off and on, determine, hey, is this going to work for my design or is this a problem? And if it does, if it's okay, you can update. And because that surface it's the same surface, it's just been moved in the NX file, you can actually move those cuts automatically to say, update this to the new version. And I'd like to have those cuts centered around the new location of the tab. So this is one of the great things about having your files opened in Creo, right? No load times, no geometry errors, and you get these automatic updates. So you don't have to manually make these changes when they give you the new motor. So here we have the bumpers, right? If you wanted to go up to the surface has changed a little bit, not a problem, right? No problem with the different dimensions. All I have to do is hit update and that geometry will correct for you. So now to switch again back to our PackBot, we're going to take a look at another collaboration tool. So the import, the open, save as, automatic update, those are all part of our collaboration extensions or in our base Creo, right? Everybody can import using the Unite technology. But we also have a tool called flexible modeling, and that is how we use Unite to actually make changes to these models. So for example, if we are working on this assembly and we want to import a different file, so this one maybe is a SolidWorks file, for example. No problem, we can bring it in. It shows up in our model tree right as that SolidWorks part. We can assemble it in, no problem. We can now create Creo parts off of this, just like we saw. Or what we could do is say, you know what, you don't need to change your motor and send it to me, right? Don't you change the sheet metal part and send it to me. I want to make changes to it. That's simpler for the process, right? It's all about what works best in your process. Well, if we're going to make changes to the sheet metal part, that's no problem. We can convert it to sheet metal, but it actually tells us, hey, wait, this is opened as a SolidWorks part. If you want to make changes to it, we're going to have to convert it into a Creo part. No problem. Unite technology does a really great job importing, right? Minimal errors, minimal issues with that. And a simple part like this, right, it comes up right away. So now what we have is this converted Creo part, and there's no feature tree still, right? Still no feature tree, but now we can make changes to it. So if we want to convert this to sheet metal, all we have to do is say, this is the driving surface. And actually, I should mention this sheet metal mode is another productivity tool of Creo. So we have options now at the top. Now that Creo knows we're working on sheet metal, you'll see we have productivity tools that are around what someone might want to do with sheet metal. So flat, flange, rip form, corner relief, bend and unbend. These are things that, you're right, if it understands what you're trying to do, it can help get you a lot of the way there and then give you those options for making the changes however you'd like to. So we'll take a look at this in a little bit, but we're going to make changes using flexible modeling. And so what you can do is just select geometry that's in your design window, whatever is up over here, and then tell Creo what you want to do. So if we tell Creo we want to move these edges, no problem. We select the edges that we want to move. And then you can drag it into place. And the way that this works is your SolidWorks model is still going to be there, in the background, but we're defining the offset. So we say we want to offset this wall by 7.3 units. And then if you actually look in the model tree, now you have this move option, right? So down you can see right before the insert here, it says move one. That's going to be your the change that you just made. So these show up as changes in the model tree that you can make edits to later. You can delete to go back to the way it was before. And these can get relatively complicated. So a couple of simple things here, but you can see if we have this pattern of cuts, well, we select all these cuts and we say, hey, there's a pattern of these. And it'll actually find that for you. It says I found 3 instances. And then you say, okay, well, add a fourth, right? It gives you the options that you would typically want when you're looking at a pattern. If you have this flange, you say, okay, there's a pattern of these as well. It finds the other instance, and then you say, I'd like to add a third. And so it keeps the same spacing, but you can make very advanced changes. You can also remove, if you want to remove items, you can do that very easily. Holes, extrudes, whatever it might be, you can remove the feature. And then you can, of course, make any kind of Creo change to it. So for example, here's the form. So it gives us options. Hey, what do you want to do to this part? Is it a punch form, die form, sketch form? And then again, it's going to give you those, right, the most obvious options up front, the ones that you're most likely going to want to change. So here we'll make the sketch to say this is the shape that I want because this is a sketched form. And then we have options for it. So what's the what are the different parameters? And then if we want to get more detailed, you can always get more detailed. So really allows you to keep it simple. It gives you the preview. And then when you like it, you can accept it. So this is a really great tool for productivity, especially for collaboration or consolidating. If you're moving from one platform to another, from something else onto Creo, now you have control over all of your designs. You don't have to rebuild them all in Creo for any reason. You can do a lot of updates and changes without having to redesign it. So this is a really great tool. Switching gears again. Here we're going to talk about surfacing for a minute. So our interactive surface design extension is our tool for freeform and technical surfacing in one easy to use tool. It's really effective at doing both the freeform and technical surfacing at the same time. So we saw earlier the freestyle modeling, that is also a surfacing tool, but if you're really designing, complicated surfaces, if you want a lot of control over those surfaces, you're gonna have organic shapes, but they come up to very technical dimensions, nozzles or spouts or something like that. You need to have the control over that, and so maybe modeling like clay isn't what you want to do. So we have an option for that as well. So right, we give you a lot of options inside of Creo. And this is built around a couple of challenges. Surfacing is a hard thing to do. It's complicated. A lot of the times concept design happens outside of engineering, so you're left going off of sketches and images. And it's from a different team altogether. So this is can be a really disconnected part of the process, and it's really important. Products sell better the better they look. So this is not something to be skimmed over. So Creo, PTC really wanted to provide inside of Creo an integrated tool that's easy for anybody to use, even if you don't have surfacing experience, that can give you those same high quality, highly complex surfaces that do what you want, but in an easy to use way. So here we are talking about some of the capabilities. It's very intuitive and it's a very flexible tool. So it can be used in a lot of different situations. And once you're familiar with the Creo parametric interface, right, it's not a different thing to learn. It's not a different surfacing tool. It's just another tab inside of Creo that you have. And it does a really good job of combining the freeform and technical surfacing into a single environment. So it lets you create these in a very streamlined manner. There's not a lot of disconnected processes trying to get these shapes. This means that you can go through a lot of different variations very, very quickly. So this is a tool that can really let you create these complicated shapes in no time at all. So you can experiment to say, hey, what better option might I have? Pull up a design exploration session, right, and run through different options. Something like that is typically the process we see. So this allows you to design the precise curves and surfaces, and everything that comes out of this is going to be highly engineered and manufacturable. So that's another thing to note about Creo in general. Creo only lets you make things that are manufacturable. There's never going to be, something that you create that you say, hey, this doesn't make any sense, we can't build this. And so that's the same with the surfacing tool. So the surfaces that you create are going to be ready to go for manufacturing when the time comes. And so this allows you to really confidently explore the different design variants, not just explore a lot of them, but to do it knowing that Creo is watching your back a little bit, right? So direct curve and surface editing capabilities make this really simple and easy. And then, of course, this is all to create products that look better, sell better, and get to market faster. You don't want to have to hold up a product for surfacing, but it is a time-consuming process, especially if you're learning a third-party tool. And so this is really something that Creo kept in mind. So let's jump to a demonstration of this. So again, we're in Creo Parametric 2, but currently the newest version is Creo Parametric 7. But again, the process is going to be the same. So if what you're working with is this shaver, right, we have this electric shaver, we can bring in the concept image. So this was designed by somebody for, right, aesthetic reasons. This is how we want it to look. No problem, you can pull those images into Creo. You can format them so that they're easy to use as a guide. So if you have a transparent background, you can resize it to fit a couple of these curves and shapes that you might already have. So, right, this curve was already existing. These parts we already have built, we're reusing maybe from a different model. And then we can start designing. So what we're going to be able to do here is actually use our style feature. So this is what we call a curve. And a curve can be a free curve, planar, right, whatever you want to do. So to start with this front plane, all you have to do is place nodes in this curve. So you can place as many nodes as you'd like, start to get that general shape out. This is typically the process. And then you can pull them around. You also have the option to look at the horizontal, vertical, normal, whatever you'd like. So if you pull that normal line, right, we want that to line up with that image, and then pull the node into the center. We also have control over the curvature. So we have this acceleration curve that we can play with. So not only can we see it, but we can also use it to create, right, those nodes. So we can change the number of degrees, and this allows us to really pull this into that exact shape. So again, really allows you to meet up with those hard dimensions that are on either side, allows you to follow that shape, but it doesn't take a lot of training to be able to do, right? This is a fairly intuitive, easy to use tool that can get this complex design out very quickly. where, might take a little bit longer if you're trying to do this parametrically or something like that. It would take forever. So, to look at a free curve, if we want to do a different view, you have this option for a multi-dimensional view. So you can see in the first dimension, if you want to bring it from that start point to the end point, and you want the middle to be somewhere along that parting line, you can pull the normal surface, change that magnitude so that it fits along, and then move it in the next dimension. So here we still have it's situated at that end point on that hard dimension, but we're able to define that normal very precisely to have it follow in that other dimension as well. So here, as you're creating a curve in the one view, you can see it appear in the other view, and then make those edits in the view that's easiest for you. So if we want to follow along this other part, right, there are a couple of ways we could do this. We could do a normal sketch and say, I want a curve with a radius of this degree, or we can follow along here. And then we can integrate those 3D curves with our regular sketches very seamlessly, right? It's almost, you don't even know you're moving from one to the next. So it's a very easy to use tool. And then to create the surfaces is really just as simple. You select the curves that you'd like to bound, be the bounding, and then you have these options for how they're coming together. So at the top, we want the surface to be normal to the curve. Over here, we want it to be tangent to that curve that we have. And then as we create more surfaces, we can see how those come together. Another great thing you can do is you can actually add control curves as you go along. So if you have something that starts in this plane, we want it to follow along that surface that we've already made. You can create the plane that you'd like to work on. You can do things like mirror. So if we want to mirror that surface, no problem. And then we can even change that as we go. So changing the curve to change the surface, right, as it intersects with that piece. And then if we move it back, we can duplicate it. We can make changes to that one as well. So again, really allows you to work however is best for you and your products, gives you these tools to make it easy to make changes later on. Surfaces are very easy to modify. So for example, here, if we want to add a surface to the bottom and we say, I want this curve, and this curve. Well, we didn't include that second control curve, if you noticed, but you can simply go back and add it and it'll pull the surface into it. So it's very simple to do. You notice that curvature continuous along those lines. So here, if you create the surface in the front, you can choose curvature, right? This is going to be our curvature continuous option. So we could have a tangent, but no, we want it to match up with the surface above it. And so this is really how you would work in this ISDX. You can check it out with your reflection, right? There are a lot of other tools in here that we're not going to get to, of course, but a really good option and really a good example of how Creo provides you with the tools to do things, very high quality surfaces, right? Very high quality products, but with the ease of use, right? For anybody to be able to take advantage of it. So the next topic that we're going to talk about is our Creo Advanced Assembly. This is a really great suite of tools inside of Creo, and the Advanced Assembly extension was built to address a couple of specific challenges. One, the time-consuming nature of the concurrent design process, right? So people are working together across teams, individuals. It can be very difficult to make sure that everything comes together at the end, comes together perfectly, and that no one's waiting for data, right? No one's waiting for someone else to be done with their part. It can be difficult to securely protect your company IP if you're sharing this out with other people and you want to get maybe other collaborators that are outside of your company. You want to be able to protect that IP while still allowing them to contribute. And there are really limited tools for being able to do this in most CAD tools in the industry today, which makes it a really slow, tedious process to do this, including that assembly process planning documentation. That's another challenge that we see pop up. So the solution here is Creo Advanced Assembly Extension, and it provides the tools that speed assembly design and streamline the flow of information from design to manufacturing. So the capabilities here enable companies to effectively manage the assembly process and reach the optimal design in less time, no matter how large or complex your assembly might be and how many teams are working on it. So a couple of the key capabilities here that we're going to touch on in the next coming slides is the top-down design process, right? This allows you to do top-down design assembly processes, also support design and build to order initiatives, manage assembly performance, especially for those large assemblies, and automate the creation of the assembly process planning. So to talk about the top-down design, the traditional way to build assemblies, right, is you're going to create a part, you're going to create another part, you're going to assemble those together, create another part from there, assemble it to that, right? And that's really bottom up. And when you have a large assembly and you have lots of people working together, that can be a really, really difficult way to try to change that process to fit, right, the assembly or the product that you're building. So top-down design provides a different way to do that, and Creo provides particular tools and capabilities to support top-down design. So the first one is the skeleton model. So you can plan the assembly framework using the skeleton model to define the assembly structure. So what are the key pieces of geometry? What's it going to look like? Where are my boundaries? What do I want people to reference? You can see in this image, it's going to be the green curves, it's the blue surfaces, it's the gray background. So you're able to create this geometry that lays out exactly what your assembly, how your assembly is going to fit together. And then you also have a reference viewer, so you can graphically visualize dependencies and relations to understand how change propagation is going to work. So you need to be able to look at the model and understand how these pieces go together, how they're related, and then you're able to understand how to best share or change your assemblies depending on what it is that you're doing. You also have reference control. So it's very easy to define best practices to manage and limit assembly component references, which is a really big deal when working with large assemblies, or even, maybe not even large assemblies, just assemblies that are going to, possibly be changed later on. To have a flexible assembly is really important to be agile and flexible in your product, and reference control is a really big part of that. So the skeleton model lends a really easy way to do that. Right? What are you going to attach your parts to? What boundaries do I want people to reference? Give them that geometry. Make sure that those are the pieces that they're referencing when creating their individual parts. Because then when you have your assembly, your assembly is finished, all you have to do is change those particular references, those particular dimensions, and then everything else will update automatically. So it really gives you control to say, hey, I want to change the whole structure of this train, and all of your pieces are going to update and give you notices if there's an issue. So another really great area of advanced assembly is concurrent design. Right here, we're again talking about that skeleton model. So if you see the integrator or lead designer might lay out the framework of the assembly and then pass particular pieces to different engineers. So if you have different people who need different parts, or you only want them to reference particular curves, no problem, just copy those into the subassembly that they're working on, and they'll have those available. Another great way that this helps support is that everything's going to fit together perfectly in the end, right? You know that all of these are going to work together, and nobody's waiting for someone else to be done. You don't have to wait for someone to be done, the internal components until you build the external components, or vice versa. You're not waiting for anybody else to have their project complete. You're all working on it at the same time, with confidence that it's going to work together. So this would be under the data sharing, and then we have inheritance models as well. So inheritance models are one-way associativity. So if you're planning something for manufacturing or simplifying for analysis, whatever it might be, changes made to the master copy, right, are going to update the inheritance model, but changes made to that inheritance model won't push back to the master model. We also have options for assembly configuration. These would be interchange groups. So these parts all go in the same way, right? Let's not waste time choosing a million references. Just choose the surface to mount it on, and we'll get to our work, right? So you predefine for a bunch of different products that you might have interchangeable in that spot. You define those references, and then you just choose the one that you'd like to have in the assembly that you're viewing. This also helps with design to order, so makes it really simple to keep a flexible assembly and flexible components. Assembly process planning can be automated with advanced assembly. So this is typically a tedious process, but Creo helps do a lot of that work for you. And then of course you have options to control those finer details, right? But let Creo do the bulk of that work for you. The last piece here is visualization and performance management. This is there are a couple of ways that this helps. The first one is that you can use the skeleton models to copy the geometry into your particular subassembly that you need to reference without having the whole thing open. So for example, if you only need to reference one curve on this passenger car train, you can bring that single curve into your subassembly instead of having to have the whole train open while you're designing your particular part. Another great thing is the version or the representation that you have open. So simplified reps, shrink wrap, which just takes the surfaces and strips out all the IP. So it's not all that data weighing it down. Also great for sending out of your company if you want someone to see your design without getting any of that information that you would have behind it. So a couple of different options here for visualization and performance management of large assemblies. So we're going to move into the demonstration here. Okay. So this example here is this train again. Here we're in Creo 6, so a little bit more updated, some extra options for your model tree. You can see this passenger car train. We're working on the passenger car. This is the skeleton model that you see here with all these surfaces and curves. And the way that this would work is you would publish geometry that you want to send to particular groups. So publish geometry is just a way of saying grouping geometry. So you can take the skeleton model and say, you know what, someone's going to need the window, someone's going to need the structure, and the floor. We'll send, that all needs to go to that structural subassembly for whoever's working on that piece of it. But somebody else might be working on the interior and they need the shape of the train. They need the divider, the quilt. They need this particular curve. They need to know the dimensions between the two. And again, the window and the framework. So again, these are our dimensions that can be controlled at the top level, and you can group them and give them into the subassemblies as needed. So this not only supports concurrent design, because now the interior group and the structural group can work at the same time, but it also helps you control those references because they have the geometry that they know is coming from the top down. So all you have to do is take that copy geometry, paste it into the assembly. So there's the structural one. If you have the interior assembly here, all you have to do is pull up that skeleton part, copy the geometry in there from the skeleton model from the top level assembly, and it'll show up. Again, the skeleton models are very easy to find. Creo knows that the skeleton model is not a production model, right? It doesn't go into your bill of materials or anything like that. And it always puts it as the first thing in your model tree. So if you're in a subassembly, your skeleton model is going to be the first thing that pops up. So it's very easy to find, right? It was just designed particularly for this purpose, so it works really well. So for example, here, if you have, this arch and you have the window and you need to start designing for the structure, all you have to do is write typical processes. So you can project this loop around, and you can actually use the particular curve. So you can either project the curve and reference it, or you can use it for your regular Creo activity as if it was the sketch that you made. So past that point, right, this is just regular Creo work. We have some cuts that you want to make to cut off the top so that it's flush with those bars, those beams. And then you want to pattern them, right? So if you have the design and you just pattern it down the line, if everybody has this. Now from the top level, let's pretend that you want to change the structure of the train. Maybe there's a new tunnel on the route that it's not going to fit through. You need to round the top a little bit more, round those corners off. Well, that's no problem. Even if your train's completely finished, all you have to do is make that change from the top level skeleton model, and now everything that references that is going to update accordingly. So for the interior, if we want to see that master representation here, the interior, it's still being worked on, but we can take a look at the wall. And now this is someone else who's working, but we can make a change, right? Here's a regular punched form. So this is a typical Creo process, part of the sheet metal design. You can use it to project onto surfaces that you might already have, right? So maybe this interior wall was from this different skeleton model, or you created it, but you can make sure that the window is going to fit accordingly, and that the window is going to be flexible by using that skeleton model geometry to create it. So this again is one of our sheet metal design productivity tools where we're making that cut there, and then we want to make an extrude. So all you have to do is, right, you want to make that a solid, not a surface. You want to remove the material. You want to remove everything past that. And now we know that this window is going to match up with that end surface, right? Because we created it by cutting that surface, and then you can pattern it down the line. So just to take a look at everything that we have here, right? If you want to look at the whole option, we have different representation options. So if you're doing work on just one particular part, maybe have things in a simplified rep, and then if you want to see everything at the end, you can always change it to a more master representation. So here we have the master rep on the top level here. So slowly you can see everything fill in. Just one more change that you're going to look at is changes to the door, but here I'd like to point out that this is a shrink wrap structure. So everything you see highlighted in green right now that's activated, this is shrink wrap that actually is out of date, right? It gave us a notification that says this geometry has changed, so we're just going to update it. Now what that means is that maybe the floor, right, this was from a different assembly, different part of the assembly, and we didn't want all of that information in our assembly. We just need to reference it. And so what you can do is shrink wrap it. Again, it just brings that surface, right? It shrink wraps just the surfaces and kind of strips that data out so you can use it as a reference. Now, one thing we're going to do with the door is to say, you know, hey, I know that this door frame came from our skeleton model, but this is a really critical part of the train, maybe for safety reasons or aesthetic reasons. If the skeleton model changes and this door is updated, this door frame changes, I want to make sure that I know about it. So we can choose either automatic to say, okay, you know what, automatically update the door if the door frame changes from the skeleton model, or we can say, no, I want to double check it for, you know, safety concerns. I want to make sure it looks okay, that nothing is going to be an issue. So we can choose to manually update that. So again, then you do your regular Creo parametric work. It's very quick and easy with our mini menus. We can shell things, right? You just select what you want to use. And then click OK. Again, you'll see up at the toolbar, right? We can change from the design window or in the toolbar. Start simple and gives you the options to get more complicated if you need to. So we can visualize all of that, right? There's a little bit more going on than that simplified rep showed us. So we can make sure we're in that master copy. If we want to get rid of everything that's not the skeleton model, we can see what we have left. And then again, let's look at everything we have in our train so far. So let's update everything to that master copy. So we have trains or seats inside. And so now let's look at how this works to make a change. So for example, we want to make a large change. We're not sure how it's going to go. You know, maybe we want to open a design exploration session to say, hey, I just want to be in a sandbox environment just in case I don't like it and I want to easily exit out of it without saving my changes. Or maybe we have a couple of ideas and we want to run through a couple of checkpoints. But either way, we can see here that we have the skeleton model up. We have this profile view. And this is the definition of the skeleton model. So a lot of dimensions going on that define all of the things that we needed throughout the profile. But we can actually make a change to any of these dimensions, and everything should update either automatically or with a notification to manually update it. And that will happen as soon as you hit this regenerate. So you'll see it's regenerating all of these different features to say, okay, the profile changed it, and now everything that was referencing those is going to be out of date. So we can actually see this one that we had set to notification. We get the notification that the door has been updated, right? That there's a change made to that geometry. And now we can take a look to make sure that we want to move forward with the change. So again, we can look at the differences. We can isolate it. You see that the orange one is a little bit right? That profile curves in a little bit further at the bottom. Looks fine, doesn't pose a safety concern. There's no clear interferences or anything like that. So you can update and then add that as a checkpoint. So again, you can see how these large assemblies can still be very flexible, how you can control the references. Of course, there's more capabilities here that we're not going to get to today. And the last little segment that I want to touch on are just a couple of things that are new in Creo. So there are all sorts of things that are new in Creo with every single release. But recently to Creo 6, Creo 7, we've had a couple of really cutting edge technologies that have been integrated into Creo so seamlessly that they really do provide a great addition to your process. And so I just want to make everyone aware of that. And to give you an idea of how Creo has been implementing things like this. So the first one is our generative design tool. Generative topology optimization is a solution that can make really interesting, radical, different sets of changes to a part based on your design criteria. So Creo actually comes up with that geometry for you based on your loads, your constraints on that part, what you're trying to achieve, right? What's your goal? Is it to reduce weight? And how you're going to manufacture it. So you can actually say, I'm going to extrude this, I need it to have a constant cross section like that one in the middle. And say, I need this geometry that's in blue. I need that to stay because I'm going to have things interact with it. Creo takes all of that into account and develops the optimal geometry for you. And then it turns it into something that's editable. So you can either use it as inspiration and design something parametrically that takes advantage of that optimization that you're now aware of, right? Where the geometry might be if it's optimized for a certain goal. Or you can, use the freestyle modeling to make changes as well. So it's not, you start from your finished design, I should say. So you're comparing different optimized results based on different constraints and loads and manufacturing ideas and starting geometry, instead of working the whole time through your design process just to get to one of those optimized results. So it's a really great tool. Additive manufacturing is another one. Again, as simple as the sheet metal things were to do, right? It does some of the work for you because it knows what a flange is, and then you design, right? What's the angle going to be and how thick is it? Additive manufacturing is very similar. You can add very complicated geometries like lattices, but do it very simply by just defining a couple of parameters as if it was a single feature. So cell size, cell type, right? Cross section. Wall thickness, whatever it might be. We also have capabilities to analyze, right? What's the best way to print this? Use it in our simulation tool very simply and easily without weighing it down too much from that lattice work. And then all the way through to connect to your printer. So, slice files, whatever it might be, tray analysis, print analysis, printer settings, printer connectivity, it's all included in our additive manufacturing tool suite. So this is really powerful as well. And then our last one is our Creo Simulation Live. So this was new to Creo 6 and had a lot of improvements and additions in Creo 7. What this is a live simulation tool used as a design guidance tool. So you can have this analysis powered by ANSYS running in the background while you're working. So this is not for the analyst, this is for the design engineer to get some insight while they're making changes to say, hey, if I move this rib over here or move this extrude to the left, what is that going to do to my deformation or to my von Mises stress? And this is available for structural simulation, thermal simulation, modal, and now in Creo 7 also fluids. So this is live and interactive. And again, allows you to explore all those different design options and get some insight to it before you would ever go to that validation stage. So again, this is not to replace our high fidelity analysis tools that we have available in Creo or whatever you're currently using now, but it's really a great complement to get a lot of that optimization and hotspot, address those hotspots early in your design process. So a lot of really great technologies. And this was the end of my presentation, so I can pass it back over to Stuart.
Emily, thank you very much. I'm impressed by the depth of your knowledge, the fluidity of your presentation, and also how you managed to finish at exactly the top of the hour. So well done.
Great. a little pressed for time, but I'm glad I got it all in.
No, that was phenomenal. Thank you very much. So I've been watching the session. I have not seen any questions come in yet. So if anyone has any, now would be a great time to do so. And you could even unmute yourself and ask away if you like. Of course, I know not everyone's interested in asking questions here, so feel free to reach out to myself or to Emily after the fact if you have any questions, whether they're about things that we presented today or other PTC or Creo related topics. But of course, just a final wrap up, I will send a recording link of the video so that way you can review if you missed any of it or if you want to go back and see it. And if you need anything related to Creo, you have any questions, you want to see anything, take it for a test drive, please don't hesitate to reach out. Well, I don't see any questions, so I'll stick around on the meeting just in case anyone has any, but that's probably a wrap. So thank you everyone for joining. Emily, again, thanks for the great presentation and seamless job on finishing up time. So thank you.
Oh, great. Thanks. Thanks everyone for your time.
Have a nice day, everyone.